Alright, everyone, today we're going to talk about finding the area of triangles. We're going to talk about finding the area of triangles in a couple of different ways, depending on what type of triangle it actually is. The very first basic ones, we all know the formula for the area of the triangle is 1/2 of the base times the height. And when looking at the triangles, first off, we have a couple of different types. If we have a right triangle, for example, very easy to find the base and the height. If we have an obtuse triangle, then we have the base that is given to us, and then what we have to do is envision the height always makes a right angle with the base. So this would actually be our height, which is outside of the triangle. In an isosceles triangle, if we recall what we talked about earlier in the year, the height, like the altitude, is also the median. So the base and then the height splits that base into two. So with those three different types of triangles, we could find the area of the triangle those ways. So a couple of examples. First off, in an obtuse triangle, in order to find the area, we need to find the height first. And so if we know that we're going to draw this in order to make a right triangle, as far as the big triangle is concerned now, we have a 30, 60, 90, and with across from 90 being 12, we can say that the height is 6. And then in the big triangle, again, across from 60 then, make this segment 6√3. But we're talking about the area of the triangle that we really wanted. It's just this triangle right here. So the height is still 6, because that is from the top of the triangle all the way down to the base, but the base is just this portion, which is 6√3 minus 2. So in order to find the area, take half of the base and multiply that by the height. And so half of 6, I'm going to do those two first, is 3. Let's distribute the 3, and oops, that's supposed to be 6, sorry, and we will get 18√3 minus 6 units squared. And then for the isosceles triangle, I'm gonna use, you can actually use any side as the base and the height, but in an isosceles triangle, it would be beneficial to use the base of the isosceles triangle as the base, and then draw in the height. And so then we know, based on the properties of the isosceles triangle that we've done before, that those sides would be 3 and 3. So then we can find the height of the triangle by doing the Pythagorean theorem. You can solve that the height is going to be, the height squared is 64 minus 9, giving us the height is the square root of 55. And so then in order to find the area of the triangle, we take half of the base of 6 and the height of the square root of 55. And we're going to get 3√55 units squared. An equilateral triangle is another triangle that we could find the area of. And in this case, it doesn't matter where we take the base. It's all the same. So the base here is 4. We draw in the height. We know that we are going to have a 30, 60, 90 triangle because it's an equilateral triangle. This is going to divide up into 2 and 2. Leaving us with a height using the 30, 60, 90 rule of 2√3. So 1/2 of our base of 4 and the height of 2√3 gives us the area of the triangle as 4√3 units squared. Now there is a special formula that you could use for an equilateral triangle. Clearly we just showed that we could do a half base times height, but with an equilateral triangle there's a special formula where we can do the side squared, √3, and divide it by 4. And so in this case, we could have done, since all the sides are 4 squared root 3 over 4, which is 16 divided by 4, and we would still get 4 root 3 units squared. So it's just another option for us in order to find the area of an equilateral triangle. Okay, at this point, I would like you to find the area of the shaded region. Okay, we're going to go over a couple more different types of triangles. First one is called Hero's formula, and this is the formula to find the area of a triangle given all 3 sides. And so first off, the formula and so what do these mean? The S stands for the semi-perimeter. Or half the perimeter. And then A, B, and C are the 3 side lengths. So for this problem, when we add up all of these sides, we get that the perimeter is 29, which means that the semi-perimeter is 14.5. So at this point, it just becomes substituting them in. The area is going to be the square root of 14.5, and then times 14.5 minus one of the side lengths of 7 times 7.5. And then 14.5 minus 10, 4.5, and 14.5 minus 12, which is 2.5. Now in some cases we'll keep our answers as a simplified radical, but in this case we will round our answer to the nearest decimal that we can. So when we simplify underneath the square root, we get 1,223.4375, and that gives us an area of around 34.978 units squared. And again, this is a specific formula that we can use when we are given all 3 side lengths. Another different formula that we can use is finding the area of a triangle when we are given this specific information. What does this actually look like? So if we were to draw a triangle, we're given that it is A, B, C, and we'll label our information. So across from A is 12, across from B is 18, and across from, angle C is 63 degrees. So this is when we are given side, angle, side. We are going to use a special formula in order to find the area. It's 1/2 of AB sine C. And again, these letters are always interchangeable. So it's half of the 2 side lengths times the sine of the angle when you are given it as side, angle, side. And then it's literally just plugging it in. And when we plug in half of 12 times 18 times the sine of 63, we get about 18.074 units squared for our area. What I would like you guys to do is think about why that formula actually works. Why is the area of a triangle 1/2 of AB times the sine of angle C? come to class tomorrow ready to justify that formula. And that concludes our section on finding the area of triangles.